In this module, we will be covering the latest feature from Nureva, which is third-party camera integration. This is a very, very hot topic at the moment, and this is proving very popular with end users who want to have automatic camera tracking and switching, because the way that Nureva have enabled this functionality, it makes it incredibly straightforward. So we'll be covering how Nureva do camera integration. We'll be looking at their camera monitoring functions, as well as an overview of what camera tracking actually means. We'll take a look at some supported devices, and then we will look at the two methodologies that Nureva have for supporting camera tracking, which is directional or coordinate based, or zonal tracking. So there are two elements to the Nureva camera integrations. Firstly, we have the ability to monitor the status of cameras through the Nureva console dashboard. When a camera is registered on console, you can see its status alongside the HDL that it is installed with, and you can then get alerts sent to administrators to tell if the camera is online or offline or not working correctly. Now, currently, there is no option for remote intervention via console for the cameras, so it still needs somebody to physically go and have a look to fix the problem. But for customers who have no sort of device monitoring at all, this is a quick way of identifying issues before they become a blocker to meetings. And because console is completely free and included with every HDL, then there is no additional cost to the customer of doing this. The second and probably more important element is support for camera tracking using the sound location data that is generated from the HDL device. Now, there are two ways to do this, but both are driven through a specific API which developers and vendors have used to create the integrations. But that API is also available to anybody who wants to integrate different technology into the Nureva ecosystem. However, the good news is that a lot of manufacturers have already done this, so there's no need for any of us to write code to make this happen. So first of all, let's look at the simple element of the camera integration, which is third-party camera monitoring. Managing meeting rooms can be challenging, particularly if you have to use multiple tools in order to check the status of the PCs, the audio, the cameras, and anything else is in there. Nureva have made it easier by including support for monitoring of third-party cameras, provided they are connected to the same PC as the HDL system. Now, just like with the HDL itself, if the camera goes offline, the status will be reported in console, and optionally, admins can receive notification in advance so they can resolve the issues in the meeting room before it actually prevents meetings from taking place. And here we see an example of console showing Lumen's, Ava Hudley, Logitech cameras and their status, and we can see in a Toronto boardroom here that it's showing that the Ava 550 is offline. That should immediately trigger somebody going to have a look to see what's going on in that space. Now let's start looking at camera tracking. Meeting room camera tracking is an incredibly hot topic today. Users want to have the most natural experience, with the active speaker effectively framed and tracked. Now, there are many solutions and many approaches to this, but Nureva's approach of providing accurate sound location data to third-party camera manufacturers enables Nureva to focus on their core competencies and the camera manufacturers to focus on theirs, therefore delivering a solution that gives maximum performance to the customer. Third-party camera tracking is available for users of the HDL300, the Legacy Dual HDL300, the HDL310 and the HDL410. In terms of the HDL410 though, because we're using 2 speaker bars with a unified map, camera tracking can be even faster and more accurate because the 410 can provide XY coordinates of the exact position of the audio. And we'll explain that in more detail as we get through the course. There is a further way of camera integration, again exclusively on the HDL410, and that utilizes the Inagini Cam 230 camera switcher. In this scenario, the Inagini is integrated directly with the HDL410, which in turn allows up to 3 cameras to be attached and switched based on zonal positioning in the room. So here we have a normal meeting room, and we have 2 cameras here, and we want to steer the camera on the long wall so that it will pick up and zoom in to an active speaker. And here again, it's steering to give a tight shot of the participants on the other side of the room. However, it may also need to switch cameras in order to get participants at the head of the table, or, as in this instance, if they are writing on a whiteboard. Whilst we could do this by steering a single camera, by switching cameras, it avoids unnecessary motion of the camera and will give a better frame for the whiteboard rather than a very side-on view. For systems using the HDL300 and 310, the camera director software can be configured to preset locations for each camera. These presets are then triggered based on the directional information provided by the Nureva API. As we saw when we explored the HDL410, the unified acoustic map provides accurate information, and it will pass XY coordinates of the exact sound location. This, in turn, allows the camera software to automatically switch cameras and steer to the precise location without the need to configure presets. Now, it's worth highlighting that as of recording of this module, Nureva have fully developed the API to provide the XY coordinate information, but not all camera vendors have fully implemented it. So if you are deploying a HDL410 with camera tracking, currently you may still need to set camera presets depending on which camera vendor you're using. Now, this is very much a developing situation, so if you're looking to deploy this functionality, please ask Ascente to confirm the current status of each of the camera vendor you're looking to use. Now, there are lots of solutions on the market already to do camera tracking, but why is Nureva's solution different? Well, their approach to camera tracking gives several key advantages over doing the same using beamforming microphone technology. Because beamforming mics do not give whole room coverage, they can only map onto specific lobes or areas in the room. Microphone mist allows the entire space to be mapped, and so give a far wider space that it can cover for camera coverage and with greater precision. Accurate directional information is passed from the HDL300 and HDL310. However, as already mentioned, the HDL410 with the 2 soundbars can accurately triangulate the exact location to provide XY coordinates of the active speaker. With accurate location data, the issue of finding a speaker across a crowded room is dramatically reduced. And finally, because the HDL is an integrated speaker and microphone solution, it knows where the speakers are located. So there is a reduced risk of false events triggering the camera and trying to lock onto the speaker bar in the room when a remote participant is active. Now, as I've already mentioned, Nureva has two mechanisms for camera integration. Firstly, the direct API integration with the camera director software is linked to the Nureva system, and the HDL provides either directional or XY coordinates to the camera software. Directional data is supported on the HDL 300, dual HDL 300 and 310, also the 410. But XY coordinate data is a function of the HDL 410 only. The second option is integration via the Inagini CAM 230 camera switcher, which again is supported by the HDL 410 only. So, as it stands at the moment, there are 4 brands of camera that have direct camera integrations through the API. And these are Ava and Lumens, and then Extron and Crestron have built-in support into their control systems, so you can download a module and therefore control different types of cameras, different makes of cameras through that module. More camera manufacturers are introducing direct integrations, and we expect to hear announcements from brands such as PTZ Optics and Sony over the coming months. Now, in terms of Ava and Lumens, they both make a lot of different cameras, and you have different versions of camera director software as well. So in both instances, you have 2 separate software or hardware applications which support camera tracking. For Ava, the PTZ App 2 only supports a single camera, so you can support camera steering but not camera switching. If you require multiple cameras, you'll need the full PTZ Link software, which is a subscription package. For Lumens, Cam Connect Lite is free software, but again, it will only support a single camera for steering. For multiple cameras, you'll need a Cam Connect Pro, which is a hardware device which manages the cameras over a network. So let's briefly dip our toe into the API itself. As mentioned, Nureva have developed the API so it sits locally, not in the cloud, and have made it open to anybody who wants to develop camera tracking applications. As we've mentioned, we have a number of vendors that have already released solutions, but there are more vendors coming in over the coming weeks and months. Given this sound location to the camera director software is what makes the solution work. For HDL 300 and HDL 300 dual systems, connection is via the console client software on a local PC. However, for the 310 and 410 systems, it can be set up through console direct without the need of a local PC. Now, if we look at the diagram on the left, this represents a typical single camera setup for the HDL 300 or HDL 310. It's worth highlighting that the sound location data is referenced from the center point of the soundbar. That is literally point 0. Therefore, the optimal position for a single camera is directly underneath or above the center of the soundbar. This then allows 8 equal presets to be configured, which each of those will be covering 17.5 degrees of view of the room. Now, in this scenario, you can have multiple cameras, but because the reference point is always the center of the soundbar, we do not recommend that you put them anywhere other than either side of the soundbar facing across the room. Now, an important point here, for users who are doing this with a HDL 300 dual system, the same is true. The camera takes the sound location data based on the center point of the primary soundbar. This is the bar that's connected into port 1 on the Nureva Connect module. As far as sound location data is concerned, it is ignoring the second Nureva soundbar. But for the HDL 410, it's entirely different. The 410 being a much more powerful device, its unified map and provides XY coordinates, which we can see on the diagram on the right. This means the cameras can be positioned wherever is most convenient and offers the best view. This in turn provides a more flexible solution for installation. Now again, as I previously mentioned, please bear in mind that this is dependent on the camera vendors releasing updated software. So please speak to Ascente for assistance if you need to specify this sort of solution. And this is how the API actually flows. The third-party application is then configured on the network. It is sending a subscription request to the Nureva console. The Nureva console is getting the sound location data from the HDL itself, which is then passed back via console to the camera director software, which in turn then sends it to the camera to reposition and steer accordingly. Now again, we've already covered this, but I'd like to repeat it because it is important. For the HDL 300, 300 dual and 310 systems, we strongly recommend you position the camera in line with the center point of the primary soundbar. That's the one plugged into port 1 on the Nureva Connect module. Typically, this means that the camera and soundbar will be in line with the main screen in the room. Not always, but typically. You can also use this mode with the HDL 410, but depending on the camera vendor's director solution, you can make it better by sending XY coordinates to the camera director software, and there is no need to set up any presets at all. This gives much greater flexibility on camera positions in the room and a more flexible and natural experience. So let's now look how we actually configure the system once the physical installation is done. First of all, there are, as we've already discussed, there are 2 ways of doing this. So for any system, you can configure it on console client, which is the local software. And in this instance, you install and launch the console desktop client. And within the client, you then go to the integration section and select camera tracking. You enable it by sliding the toggle to the right, and you'll then get a confirmation message. If you're using Console Cloud, the approach is basically the same. You go to console.nureva.com and log in and select the room that you want to work on. Once you've done that, you go to the integration section, select camera tracking in exactly the same way, and you'll get a confirmation message. From now on, the process in both console client and console cloud is exactly the same. And the first thing you need to do is to establish a connection between the camera director software and Nureva console. And in order to do that, you will need to get the IP addresses of both devices. In console, under the camera tracking section, you will see the HDL's IP address plus a suggested TCP port for communication. This is completely configurable. The default is 8931, but you can change that to whatever works on your customer's network. You then need to give permission for the camera software to access the sound location data. You do this by entering the IP address of the PC running the camera director software. Or if you're using Lumen's CamConnect Pro, it's the IP address of the CamConnect Pro hardware. You then repeat the same on the camera director software, and here we can see Ava PTZ Link and the Lumen's CamConnect software. And very simply, to complete the connection, you then just enter the port, the same port, and the IP address of the HDL. Once this is done, if everything is set up correctly, the solution will be live and passing data between the two pieces of software. You'll know it's working because you will see under the azimuth angle within the software package, which you can see here within the Lumen software. When there's noise in the room, it will detect it and one of those lights will illuminate green. At that point, you know you've got live data passing between the two devices. The next stage is to go around and configure the presets on the camera based on the azimuth angles that you can see appearing in the software. Now remember, because the HDL is mounted on a wall, you've only got 180 degrees, and so you have 8 sections of 17.5 degrees to play with. As you move around the room, you'll see where these angles are by the corresponding green lights on the camera software. Follow the instructions within the camera director software to align the camera to each of the 8 sections if you want to use all 8. If you have multiple cameras, you can also configure the software to switch if a camera has a better view of a particular zone. Now, this does take some time to finesse, but it is worth the effort. It is also good practice to set a home setting for the camera. Normally, this would just either be looking straight out in the room, or for users who don't like a camera pointing at them the whole time, preset 0 could be pointing at the wall. You can then have the option to set up a sleep timer in the camera director software, which will return the camera to the home setting after a determined time. Now, once this is done, you can then have a productive meeting. Now, I'm going to show you a quick video done in our Leeds showroom where we mocked this up. New meeting, and I can now present, and the camera is going to follow me. And then once I'm done and I come and sit in my chair, then the camera will switch to me here. Now, if Tom starts to speak,
then the camera will move over to me. And there we go.
Okay.
Now I am talking, and the angle should move to me. And finally, once I begin talking, the angle should move to me.
And there we have it. So this is 2 Lumen's cameras running on the Lenovo PC, running Margot with the 105 Jupiter touchscreen. Okay, so as you can see from that very quick mock-up, we had a couple of cameras, so we were doing camera steering and switching, and that took about 15 minutes to configure. So let's now look at how we do camera zoning using the Inagini Cam 230 device. Now, the Cam 230 will switch camera sources depending on its input, and that can be anything. That can be a manual input from buttons on the front. However, Nureva have integrated it via the API, so you can then switch cameras, and that is based on zonal information as opposed to anything else. And as already mentioned, the Inagini integration is only available on the HDL410 because only the HDL410 can provide that XY coordinate information and apply that to specific zones in the room. With the Inagini solution, we can configure up to 3 cameras, and depending on the cameras we're actually using, these can be fixed or they can track within the zone as the customer requires. Here on the right, we can see the cabling diagram. So we've already seen the how this applies to the standard setup. So the top half of this basically the same as normal. However, we've now added in the Inagini Cam 230 with 3 cameras attached. We have 2 USB and we have a HDMI cable. The Inagini is attached to the same network as the HDL410, and this is important. Both devices must be directly connected to the network. And that is the basic physical installation. In terms of then how we configure the solution, firstly, we go into the Cam 230 web interface. The default IP address will always be 169.254.10.10. And you'll then need username and password, which is admin in both instances. Obviously, you can change this once you've got into it. The solution works on software version 2.2 or higher. The first thing to do when you get it out of the box is to upgrade the firmware. The latest release as of point of recording this video is 2.7. Once you've upgraded the software, you then need to generate a what we call a REST API token, and this is done in the system section of the Cam 230 web interface. Copy that down because you'll then need to paste that into the Nureva console. Now, once we've done that initial setup on the Inagini, we move across to the Nureva console cloud application. And it's important to note you can only do this through console cloud. You cannot do it on the client. So the first thing you need to do, if you haven't already done it, is enroll the HDL410 into console cloud and make sure everything's updated to the latest software. Go to the room's dashboard, select the HDL410, go to integrations and select Inagini camera switching. Enter the IP address of the Inagini unit and the port. You then need to paste, and the port by default is 443. You paste the REST API token that you've taken from the Inagini web interface and you put it into the network integration settings. And once you've done that, you hit apply. Once that's done, you can then go and open the coverage map. If you'll know immediately if the integration has been successful, because camera switching controls will be visible and the CAM230 and its connected cameras will be shown under devices. At this stage, the first thing you need to do is to confirm the room dimensions are correct and adjust them as necessary. Now, it's possible you may find that the HDL soundbars are not shown in the correct locations. At this stage, power cycle the HDL system and recalibrate if the HDL bars are not in the right locations. Once the room dimensions and bar positions are correct, hit apply. This is really important. If the bars are not shown in the right locations in the room, on the map, you will not get accurate sound location data and your zones will not work properly. Once you've done all that, go to the zones section. Press create zone and a zone will appear on the map. You then drag that zone within the map to the required location. You adjust the size as appropriate and you give it a name. You test that the zone is working correctly by speaking whilst walking around the room, and the sound location data will be displayed on the map, which is then refreshed every minute. Once you're happy that that zone is correct, again hit apply, and then you can repeat for the remaining zones that you want to configure. Next, go to the camera switching section. Firstly, select the default camera. This will be the camera that the Inagini switches to when voices are not detected. Next, select the time icon and assign trigger times for camera switching and for the system to revert to the default camera. Finally, assign a camera to each of the zones that you have already defined, and once you've done, hit apply. You've now configured the solution. Now, a couple of key points. A zone will not be configured if it's outside of the room borders, or it's overlapping another zone, or it doesn't have a name, or it exceeds 50 characters or has the same name as another zone. So it's all fairly basic stuff. However, what may not be obvious is it's really important that you leave a gap between zones. If zones are touching and somebody is sat in a chair which is on those two zones as they touch, the cameras are going to get really confused and do very rapid switching. We recommend at least a 50 centimeter gap between each zone. Another important point. Sound location information is shown on the coverage map for voices over 45 decibels. However, camera switching is only triggered by voices over 60 decibels and that are talking for the time that you've specified in the timer section. So the upshot of that is if you've got somebody who's quite softly spoken and they are sat furthest away from the soundbar, that potentially could be a problem. If you've got somebody softly spoken, they should be sat closer to the soundbar than somebody who talks a little louder. Now, I've talked about this for quite a while. Let's show you an example of it in action. So here is a quick video recorded by one of my colleagues, George, in our lead showroom, showing how Inagini camera switching works.
Hi there. Today I'm in Ascente's Leeds Experience Centre to show you the integration between the Nureva HDL410 and the Inagini CAM230 switcher. In this room I have 3 different brands of cameras set up to cover one room, and their cameras will be switched to depending on where I am speaking. Right now in the presentation space at the front by our Jupiter ultra-wide screen, I'm speaking and being tracked as I move using the PTZ Optics Move 4K camera. Now, that's tracking me without using Nureva's technology, that's PTZ Optics' own. But then if I move into the center of the room, and I begin to speak here, you'll see that we will switch to the Hudley L1, which will then use its genius framing technology to frame me as I'm here. Now, as I then move towards the back of the room, towards the second presentation space, and I begin to speak here, you will see that we'll switch to a still camera that is showing just this screen and this presentation space. As you can see on our 105-inch Jupiter screen, this room has a heat map of where I've been speaking. And within that heat map, you can actually create little zones that you can use to trigger camera switches depending on where you're speaking in the room. Right now, I'm in zone 1. In the middle of the room, I was in zone 2. And at the front of the room, I was in zone 3. And this works with nearly all cameras. And if you need to learn more about InnoGeni and Nureva's integration, then just get in touch with Ascente.
So now I've switched over to our instance of Nureva console. And as you can see here, we have two systems set up with the InnoGeni system. One up in Leeds, which you've seen George just doing a demo on, and another one in our London Experience Centre. If I look in our London setup, then I can see the zones on the front page, and this is very, very simple. I can then go to the coverage map, which won't have a lot of data on it because there's nobody there currently. But what I wanted to show you was the different setups. So here is where in the room dimensions is where we actually set the size of the space. We then go into zones and we can manipulate those zones within that space. And then finally we go to camera switching, where we can select our default and set the timer to switch. So very, very straightforward to use and configure once you've got the InnoGeni device and the HDL410 talking to each other. So in summary, the way that the HDL series handles camera integration is very comprehensive. You have multiple ways that you can use camera steering and switching, taking advantage of either directional or the XY coordinate information that's coming out of the HDL device. This makes the Nureva solution very, very straightforward to deploy and specify. If you need any help around this at all, then simply call Ascente and we'll be happy to help.